nobody announced it. There was no press release, no Elon tweet, no keynote stage, just two semi-tractors pulling something enormous through the Nevada desert. A machine so large, it needed a triple-axle trailer just to carry it. Workers at Giga, Nevada watched it arrive and said nothing publicly. But in manufacturing, a machine that size doesn't show up by accident. It shows up when something is about to be built at a scale most people aren't ready for. This is the story of how Tesla may have quietly solved its hardest problem, and why almost no one noticed until it was already done. To understand what's happening now, you have to go back to 2017. That's when Elon Musk stood on a stage in Hawthorne, California, and unveiled a truck that looked like it came from a different decade. Sleek, aerodynamic, electric. A Class 8 heavy-duty truck unlike anything the freight industry had ever seen. The crowd went wild. The industry laughed for the next 8 years. The Tesla Semi became the symbol of everything people loved and hated about Tesla. Missed deadlines, a product that always seemed to be 2 years away. Even when the first truck started rolling out to PepsiCo in California, the skeptics barely flinched. A handful of trucks on short regional routes wasn't exactly the revolution Musk had promised. And deep inside Tesla, quietly, without a single announcement, the real version was already being built. But this only matters once you understand what they actually changed. Because the Semi Gen 2 isn't an upgrade. It's a different philosophy wearing the same name. The first clue wasn't a leaked document or an insider source. It was a stamping machine. In late August 2025, flyover footage and ground-level sightings captured massive manufacturing equipment being delivered to the section of Giga, Nevada, dedicated to semi-production. The machines were enormous, logistically complex to transport, and completely unexplained by Tesla publicly. In the automotive world, you don't acquire equipment at that scale to run experiments. Stamping machines of that size exist for one reason: mass production of large structural components. The moment that footage circulated among manufacturing analysts, the conversation changed entirely. And this is where the story starts to get uncomfortable. Because sitting alongside that equipment delivery were other signals that on their own meant nothing. But together, they started to form a picture. Tesla had been quietly expanding its workforce at Giga, Nevada. Thousands of additional workers. Elon Musk confirmed at the shareholder meeting that volume production of the Semi would begin in 2026. And drone footage in early 2026 showed 46 stations across the United States nearing completion, infrastructure capable of delivering 1.2 megawatts of charging power. That's not a pilot program. That's the beginning of a national grid built specifically for one vehicle. You don't build that unless you're planning to put a very large number of trucks on the road very quickly. Which brings up the rumor that most people dismissed the moment they heard it: 30 seconds. Somewhere in the circles of Tesla-focused investors and manufacturing analysts, a claim surfaced that the new Giga press technology could produce a truck frame in 30 seconds. Taken literally, it sounds absurd. No one builds a Class 8 truck in 30 seconds. But that's not actually what the claim means. Tesla's manufacturing approach, what they call the unboxed process, doesn't work the way traditional assembly lines work. Instead of building a vehicle sequentially, one station at a time, Tesla breaks the vehicle into large modules, manufactures them in parallel across the factory floor, and then joins them together in a single final step. If the major structural components are cast as single aluminum pieces using an ultra-high-pressure gigapress, and the battery pack itself is engineered to function as part of the vehicle's frame, then the time spent at final assembly collapses to something unrecognizable compared to anything the trucking industry has ever done. 50,000 trucks per year. That's Tesla's stated production target for Giga, Nevada. To put that number in context, the entire U.S. Class 8 truck market is projected at around 245,000 units in 2026. Is planning to capture roughly 1 in 5 of every heavy-duty truck sold in America in the first year of volume production. With conventional manufacturing methods, that number is a fantasy. The only way it becomes remotely possible is if the production process itself is unlike anything that has ever been applied to a vehicle this size. And that's exactly what the physical evidence suggests is being built. Right now in Nevada, the truck itself tells the same story, just from a different angle. The Gen 2 exterior is immediately recognizable as a Tesla flat surfaces. Sharp angles, a full-width LED light bar running across the front fascia, the same visual language as the Cybertruck and Cybercab. But these aren't just design choices. Every surface decision is tied to aerodynamic performance. The flatter, more steeply sloped front end keeps airflow attached to the body longer. The slimmer windshield reduces drag without compromising the driver's field of view. The front bumper integrates active air shutters that open and close dynamically depending on load and conditions, a feature borrowed directly from high-end passenger cars, now applied to a 40-ton freight vehicle for the first time. The result is an energy consumption figure of around 1.7 kilowatts per mile, a number that most diesel trucks running on fuel that's been refined and combusted for over a century simply cannot match. Inside, the cabin has been extended by roughly 50 to 70 centimeters compared to Gen 1. The side windows push further back. The implication is a sleeper compartment, a bed, storage, potentially a refrigerator, and an entertainment system for drivers on multi-day hauls. Tesla kept the central driving position, which gives symmetrical visibility in both urban and highway environments. Two 15-inch touchscreens sit on either side of the driver. Physical buttons are nearly gone. The interior is built to be durable and easy to clean, which sounds minor until you consider how many hours a long-haul driver actually spends inside that cab over the course of a year. Below all of that, the structural 4680 battery pack does something no diesel truck has ever had to consider. It doesn't just store energy, it is the frame. The pack is load-bearing, which lowers the vehicle's center of gravity, improves cornering stability, and reduces the risk of rollover when crosswinds hit at highway speed. The charging port sits behind the cab on the left side, compatible with the 1.2 megawatt megacharger, NET-WORK, capable of going from 5% to 70% charge in roughly 30 minutes. That's the number logistics operators actually care about because downtime is money. And 30 minutes at a charger starts to become a genuine operational argument against the diesel refueling stop, DHL noticed. The company, one of the largest logistics operations on the planet, ran trials with a Tesla Semi inside its U.S. fleet and came away interested enough to discuss expansion. Jim Monkmeyer, president of transportation services at DHL, said publicly that the results satisfied them. DHL has committed to electrifying 30% of its fleet by 2030 and has stated it won't walk back that target regardless of market conditions. PepsiCo is already running 86 Tesla Semis in California right now, on short and medium routes, using them precisely where the economics make sense. And while Tesla has yet to announce an official price for Gen 2, competing electric Class 8 trucks from Volvo and Navistar are currently sitting at around $400,000 per unit. The expectation, and it isn't an unreasonable one, is that Tesla, at 50,000 units per year, could come in at roughly half that figure. And then there's the piece of this story that Tesla has been most careful about: full self-driving. The plan, according to multiple sources, is to introduce supervised FSD to the Semi Gen 2 as early as 2026 hands-free on highways. Drivers still in the seat, but not necessarily in control. On a passenger car, that conversation is already complicated. On an 80,000-pound freight truck moving at highway speed, the regulatory, legal, and ethical questions multiply in ways nobody has fully resolved yet. Any incident would face a level of scrutiny that makes anything in the passenger car space look manageable by comparison. But here's what makes the Semi uniquely positioned for this. Compared to any other truck on the road, the sensor suite is built for it. The central seating position eliminates blind spots that plague conventional cab designs. The electric drivetrain removes the mechanical complexity that makes traditional trucks fundamentally harder to automate. The architecture of this vehicle, from the structural battery pack to the camera pods above the wheel arches, was not designed around the driver who was there today. It was designed around the possibility that eventually the driver might not need to be there at all. That's the question Tesla hasn't answered, and it's the one that matters most, because if the manufacturing works, if 50,000 trucks roll out of Nevada in 2026 at a price point that cuts the competition in half, and if FSD follows on the timeline Tesla is projecting, then the Semi stops being a truck. It becomes an argument that the entire structure of long-haul freight in America The drivers, the mechanics, the independent operators, the culture that has existed around that industry for generations, is standing at the edge of something that doesn't reverse. Tesla didn't announce this. They delivered a stamping machine in